All right. Good evening, or good afternoon, everyone. My name is Anders Halsberg, and I'm here to talk about what's new in TypeScript. Just actually out of curiosity, by show of hands, how many of you use TypeScript already? Wow. And how many do not and are here to learn about it? So we're about half and half. Good, good. So that should work. So the TypeScript project is really summed up on this slide right here. It's about making JavaScript scale. It's about making it easier to build medium to large applications in JavaScript. I'm sure all of you have noticed the explosive popularity of JavaScript that has occurred at least over the last 5 years and only seems to be accelerating these days. Fantastic developments in browsers like with V8 and the Chakra engines, with Node.js on the server side, NPM for package management, excellent frameworks like Angular and React, and there's just so much going on, and it's all powered by an incredibly active open source community. But at the core of it is, of course, JavaScript. And JavaScript was never really engineered to write large applications. It was, in fact, invented in about 3 weeks in the mid-90s as a quick response to Java, and Netscape added it to their browser. And for Brendan Eich, built it in 3 weeks, and for having only 3 weeks, he actually did a fantastic job. But you can only do so much in 3 weeks. And JavaScript was perhaps intended for 100 or maybe up to 1,000 lines of code, And now, with regularity, people are building 100,000 line apps, if not million line apps. And that's very, very hard to do in a dynamic programming language that lacks all of the concepts that we are accustomed to for large-scale application development. In particular, up until recently, JavaScript didn't even have classes or modules. But in particular, JavaScript does not have a static type system. And if you think about what it is that powers all the intelligent tooling that we know and love in Visual Studio or in Eclipse or in JetBrains tools and whatever, it's all about having static types so the IDE can reason about what's going on in your program and give you invaluable features like statement completion, go to definition, find all references, refactorings, et cetera, et cetera. So, as we thought about what we could do to make large-scale app development easier in JavaScript, we decided to build effectively a statically typed superset of JavaScript that compiles to plain JavaScript. So during development, you get an experience of having a grown-up language with all of the features that you want, and the language starts with JavaScript, so any piece of JavaScript is already TypeScript. But then you have all these additional features, but then when you compile, all of the features disappear and you're just left with JavaScript again. Now, the TypeScript project was built to work on any browser, on any host, and on any operating system. And the entire project is open source. In fact, the TypeScript compiler is written in TypeScript. We host the project on GitHub. We've been there for about 2 years now. I personally write a lot of code, and I'm having more fun on this project than I've had in decades. I love writing code, and there's a great community behind us, a great team, very active, and we tend to release early and often. So, to sum up the two things, really, there are really two things that TypeScript bring to the table. One is great tooling enabled by static types, and you'll see that in all of the demos. Another is features from the future today. The thing that TypeScript allows you to do is it allows you to use all of the latest features from the latest version of ECMAScript, which today is called ECMAScript 2015. It used to be called ECMAScript 6. And that includes modules, it includes classes, it includes Lambda functions, et cetera, et cetera. But of course, a lot of these features aren't actually available in the wild. In fact, if you look at sort of this thing that we call the feature gap, and let's start back, say, a year ago. A year ago, the state of the art of JavaScript was that ECMAScript 2015 was almost complete. And basically, there were specs for all of these new features, classes, modules, et cetera, et cetera. However, on the server, Node.js had only gotten to about ECMAScript 5. And on the web in the wild, well, it wasn't even clear that you could assume ECMAScript 5 at that time. So there's this gap of where you want to be as a developer, but where the target that you actually have to run on is at. And because JavaScript is extremely heterogeneous, you know, you got to target possibly down-level Android phones that never get updated, that run on old versions of JavaScript. Well, this gap could be big, and you need something to fill it. And what TypeScript does is it allows you to use most of the new features in ECMAScript 2015, and then we can down-level compile them to JavaScript that works in ECMAScript 3 or ECMAScript 5 compliant browsers. And I'll show you that in some demos. And then you might go, well, geez, well, that's wonderful, but isn't this gap going to go away once everyone, you know, gets all of the ECMAScript 6 features implemented? Well, if you look at where we're at now, it turns out that the gap just sort of slides. Right now, ECMAScript 2015 is done, but the committee is now working on new features in ECMAScript 2016, like async await and other things that are coming in. And still, the web in the wild lags behind. Maybe you can assume ECMAScript 5 today, but it's not even clear. So this gap continues to be there, and that's why you need tools like TypeScript. Not just because of all the great productivity that we bring from static typing, and you'll see that in the tooling, but also to close the gap, so to speak. Okay, so that's enough intro. What I'm going to do is jump and then show you what the product looks like in action. Let me switch to a directory where I have a little demo here, and I'm going to use in my entire session today. I'm going to use Visual Studio Code, which is our open source code-focused editor that works on not just on Windows but also on Macs and on Linux. So everything you see me do here, you could do on your MacBook or on your Linux machine. Here's a JavaScript file. It's just a plain JavaScript file. That's all I have in this directory here. And it's a simple little JavaScript function that sorts an array. Now in here, as I am like hovering around, you'll see that we don't really know a whole lot about this code. There's a parameter called a, but we don't know what its type is, and we don't really know what the types of x and y are therefore. We do know there's a function called sort by name, but we don't know that it's supposed to take an array. So I can write code like, you know, we can give you statement completion. There's a sort by name, but we can't like validate that you pass it an array. So it's very easy to write code that just plain old doesn't work, right? Now, let me try to take this file and simply rename it to .ts, which is the extension for TypeScript. There we go. And lo and behold, nothing changes. Because TypeScript is a superset of JavaScript. But now I get to use additional features. For example, this function here is really supposed to sort things by names, and let's say these things are persons, so I could insert an interface declaration that declares a person as a thing that has two properties, a name and an age, and then I could say that my array is actually an array of persons. And now, all of a sudden, you'll see that things, things start to light up here. I get some red squigglies, first of all, down here, because I'm not passing an array. And second, there's something wrong here with this local compare. Now, I also get features. Let's say that I was writing that line of code. If I say return x dot, you'll see that we actually know that x is a person, and we can give you statement completion and show you the name and the age properties that you just said were there. So I can just type that, and then we know that name is a string, so hey, I can show you all the methods on string, including locale compare. Apparently I had misspelled it, but since it's JavaScript, no one tells me until the program runs, right? But now, you actually get to know about it. So we can fix these errors, and that's That's great. We can also, because we are using TypeScript now, we can use later features. For example, I can use lambda functions here. Instead of writing a function literal, I can write a lambda. Now, let's try to actually save this. Let's go out, and then let's try to start the TypeScript compiler. Well, let's actually do two things. No, we'll just start on. We'll start the TypeScript compiler in, oops, we still didn't fix the error down here. Let's fix that. I started the TypeScript compiler in watch mode, which means that it sits and just watches. And whenever I save files, if these files are part of my program, then it recompiles them automatically. And now we can just leave that in the background. Then we can try to go into two panes here. Let me actually maybe zoom it down a little bit again. And then over in this pane here, we will look at the JavaScript file. And so here you see the TypeScript, and here you see the output JavaScript. And lo and behold, it's exactly the same. All that happened was that the types went away. And that's really how TypeScript works. It just removes the types and outputs JavaScript that'll run in your browser. Although you will note that one thing changed here. We changed the lambda function into a regular function because lambda functions don't exist in ECMAScript 5. They only exist in ECMAScript 2015. Indeed, if I start using features like, let's say I used a class, let's say, inserted a class here, and let's save. And now you'll see that the compiled version of that is actually down level ECMAScript 5. So we compile ECMAScript 6 to the patterns that you had to use in ECMAScript 5 in order to do classes. We can actually change, let me just start and create a config file here and start the compiler and watch again. And then let's go back in here, and then let's try to change our output target to ECMAScript 6 and save that. And now you'll see that our code jumps and becomes ECMAScript 6, but with the types removed. So you can actually sort of move the slider up and down. You write your code as if the world is the latest and greatest, and then you can target whichever level you want to in your browser. Other features we can offer now, for example, is like in here, as I'm writing my code, we know what the properties are that you're supposed to, so we can give you statement completion as you're writing, like that. Also, we can offer cool features like refactoring. For example, notice here's a name property, and you'll see that we can highlight all the places that that's used, and I can say rename it to full name, and you'll see that it changes in those three places. But notice the name property inside greeter didn't change because that's a different type. It's a different property. And because we actually have semantic knowledge of what your code does, we can give you safe refactorings, which previously was impossible in JavaScript. And that's why very large JavaScript code bases tend to become read-only. Once you get to a couple of thousand lines of code, you dare not touch anything in there because, oh my God, it's just going to blow up. We're just going to hack around it and put a wrapper and something, you know, because nothing, unless you wrote unit tests for everything, you will not know whether your changes work. But here, we can actually have the computer reason about it for you. So that's a quick intro to what TypeScript does. Let me try to go back to the slides. And let's talk a little bit about where we are right now. So in the last year, we have released 4 versions of TypeScript. The team works really fast. We tend to be on a 3 to 4 month cadence. So since the last build, we've released 1.5, where we did the core features of ECMAScript 2015. Then 1.6 did the rest of ECMAScript 2015. Plus, we added support for React and JSX, and I'll show you that. In 1.7, we added async await support on Node. And other features, I just sort of picked some of them. And now in 1.8, we're supporting JavaScript and TypeScript projects, which sort of sounds backwards, but I'll show you what that looks like. In fact, these are all the features that I could fit on a slide that we've implemented in the last year. There are many more. If you go to GitHub and go to our project page, we have a roadmap where you can go see every feature linked to all of the pull requests or issues that led to that feature being implemented. You can follow the entire implementation history of everything. So this is just sort of a little subset of what we did. Okay, so let me jump back now, and instead of doing intro demo, I'll show you some of these features that we implemented in the last year. And then at the end of the talk, I'll show you some of the features that we're working on for the future. Okay, let me get out of this and kill this guy. And let's go to demo/ng Reddit here and fire up our editor. You can't, oh, sorry. There we go. So I went to a different directory and opened up a project called ng Reddit, which is a Reddit reader written using Angular 2. I'm sure some of you, or many of you, know that the Angular team at Google is actually using TypeScript to write the next version of Angular called Angular 2. We teamed up with them about a year ago, and they have been full on with TypeScript since. In fact, most of them use Visual Studio Code as well. It's a great partnership. Brad Green is here, and will be giving a talk on Angular later at the conference, so catch that if you can. Now this project here, I've already set it up. Basically, you can see there's a whole bunch of node modules that we've npm installed, like Angular and ES6 Promise and RxJS and so forth. And we've installed a bunch of types that came from the community. One of the cool things about TypeScript is that even if a JavaScript framework wasn't written in TypeScript, you can go write down all the type definitions for it. And then we can slurp them up and then give you intelligent experiences in the IDE. And the community has really gone hog wild on that. There's a site on GitHub called Definitely Typed, and they have collected now more than 1,500 frameworks are covered with type declarations. So pretty much any JavaScript framework you pick, you'll be able to use with TypeScript and get great experiences. But the cool thing, too, is that even if there are no type declarations, you can still use it. You just don't get the Cadillac experience, if you will, with statement completion and so forth. It just is as if you're writing JavaScript. OK, now in this project here, we can, of course, navigate around. I can go to definition on component, and you see it jumps into the declaration file in here. And this is all of the type declarations for Angular. I can, say, go to the declaration for observable, and then I jump into the RxJS node package. And so you can see we actually have, this is a large project with a lot of files, and you get an experience that is very similar to what you're used to with, say, C# or Java in a grown-up development setting. Now, this app here is a little reader for Reddit. Let me try to go to Reddit and show you the subreddit so there's this Reddit called Aw about cute animals, and we thought, hey, it might be fun to have a little reader for that. So in here, we can click on the links and we can see pictures of dogs with big ears or foxes having fun indoors, et cetera, et cetera. Now, there's actually a JSON feed coming off of this subreddit, so I can ask for all of that data as JSON. And what we're going to build now is a little app that does that and then shows it formatted differently using Angular. So going back to our project here, what we have here is basically an app that asks for JSON providers to be included in Angular, and then we display the Aw subreddit. And in order to do that, we just hit the JSON feed, and then we reformat our data right here. Now, the experience of writing this line of code here, for example, let's just try to comment it out. And let's say I was writing this line of code here. You'll see that when I say .map, First of all, we get statement completion on, because we know that you declared feed data as an observable, and we can flow the types through all of this stuff, give you statement completion. So if I say result arrow, then I can now say result.json. And now what I can also do is I can go write down the types for my JSON. So here's a sample of the JSON that comes back from Reddit. And it has, as you can see, an object with a data property that has children, that has data, that then has author and whatever the things that we're interested in. Now, if I go look at this file here, I have written down the type declaration for the JSON feed. So I've actually declared a JSON API response as those three properties, and then I've declared, the properties that I'm interested in and their types. And now, when I'm writing my code over in main here, I can simply say treat the JSON as API response. And now, we get statement completion based on the types that I just wrote over there. So data.children. And this is an array, so we can say map on that guy, and that gives us a child, and then for each child, we can say child dot, and here we have the data property, and here we have author, domain, subreddit, as we wrote it down over in the declaration file. And that's sort of how you wrap types on top of your JavaScript, and then the IDE serves them up and validates them for you as you go. Okay, let's try to run the app and see what happens. In fact, I'm just going to go and I'm going to start HTTP server, which is the node HTTP server, in this directory. Then I'm going to go back to this guy here, and I'm going to hit localhost 8080. There we go, and refresh. Now, you'll note that I just went there. I started the HTTP server and went to localhost. I didn't even compile. In fact, this particular project is set up to use a module loader. If we go back here, this guy uses the System.js module loader. And the System.js module loader allows you to configure transpilers that run in the browser as you're loading the app, which is not what you would do, of course, in the final setup, but it's great for development because you just treat your TypeScript files as if it's something that could go over the web. And then the TypeScript compiler, because it is written in TypeScript and therefore compiles to JavaScript, can be embedded in your web page by the module loader, and the module loader can arrange for compilation to happen. And now you can just sit and have exactly the same workflow that you would have in JavaScript. Edit, save, go refresh the browser, and things just happen. That's pretty cool, isn't it? Yeah. Okay, that's a quick look at Angular. Now, Angular is not the only UI framework that we support. Another very popular framework out there, and one that's gaining rapidly in popularity, is React from Facebook, another open source UI framework. So let me show you this very same app, but this time written using React. So we'll shut down this guy. And we'll go to demo and go to React Reddit instead. And we'll fire up Visual Studio Code on this project. And it actually looks pretty similar. We can navigate to imports here. And first of all, you see that we have, in fact, the very same file, the API response and the submission. So that file is exactly the same between the two. But here instead, we're using jQuery, we're using React. And I can go to the definition of these guys and see how all of that code was written. Also, we have a bunch of node modules installed and so forth. Now, one of the things you'll note with React is that it is based on a markup embedding technology called JSX. So React allows you to write markup inside your program. And it actually allows you to find new meanings, new tags, if you will, for the markup with new attributes that go on those tags. And so here, for example, you see that the program renders a div and puts inside that div these components. that in turn are a list of submission components. And if I now go to definition here by pressing F12, you'll see that we actually understand the markup and we allow you to go to definition on markup components and jump around to where that component was declared. This particular submission component is written as a stateless function, which is a new feature that recently got added to React. It used to be that you have to write them as classes. And in here, you'll see that we actually sort of take apart the submission and put it into HTML elements. And all of this markup then gets translated into code that dynamically instantiates the DOM, and then event handlers get attached and so forth. That's sort of, in a nutshell, how React works. Now, one of the cool things here, too, is, let's try to open these two again here. I can actually do refactoring on my component. So let's say that I want to call this, instead of submission comp, I want to call it Reddit entry. You'll see that we changed here, but if I go to back to my main file, you'll see that we also changed in the place that I'm using it over here, and we changed it here where we import. So you can actually do refactorings on JSX markup across large projects and have it all be type safe. I think that's pretty cool. All right, now before I run it, let's just look at how this app is put together. You'll see here that it basically loads up jQuery, React, React DOM, and then it references this thing called bundle.js. And bundle.js is actually a bundle of all of the files in my program. This program was written to use another JavaScript tool called Webpack. So in order to run it, I first have to Webpack it. So let me start up Webpack here. Let me remind myself what here. So I'll say start Webpack-W. And what this does now is it starts a background process that Webpacks my program as I'm developing it. So it's already completed here, and it has basically built this bundle.js. And the way it builds it is, if you look at webpack.config.ts, you see that it uses tsloader, which is, again, a community-provided loader that loads the TypeScript compiler and has Webpack invoke it to transpile your code, and then it bundles all of the modules together in one single file that can be downloaded with your app. So the bundle.js then ends up looking something like this. You know, here you see our code sitting in here that we wrote, but you see how the markup has been changed to react.createElement and so forth. That's the TypeScript compiler compiling the JSX into the appropriate code. Let's try to run this. So we'll go to the browser. Well, actually, we need to start HTTP server in this directory now, like so. And then let's go back to the browser, and then let's simply refresh. And now we see the very same app, but this time written using React. Thank you. Follow the links and so forth. Now, it kind of would be cool if we didn't have to follow the links in this reader here. What if we could show the images directly? So let's try to modify our app to do that. So we'll go back here and go back to the main app here. And you'll see that conveniently I have a line of code here I can uncomment, where I filter all the submissions down to those that contain JPEG or PNG files. But then I also got to render those. So let me go back to the component here. And then let me add a single tag down at the end here, an image tag. And you'll note here that we give you statement completion on the markup, right? So IMG, and then we know what the properties of an IMG are. There's a source property. And here, now I can actually reference the local variable, the parameter that was passed in, and get submission dot, and of course we get statement completion off of the interface declaration that we wrote. and I can say style equals, and here put in image style. Whoops, not what I wanted. Image style like that, and close off. And then we'll save this guy, we'll save this guy. You'll note that as I save, Webpack runs and automatically bundles my app, so I don't have to worry about like compiling anything. I just save. And then I go back and here refresh, and now we see images in our little reader. Thank you. Oh, look at those. All right. Now, let me stop the HTTP server here. Now, the code that I just wrote, of course, isn't really how you can get away with writing your code. You'll see here that I'm actually doing cross-domain requests, which obviously wouldn't run in the wild. I would have to go back to my own server and have it serve up, you know, whatever. So really, if I had to write this, I would have to have my server make the request to Reddit. Well, so that's an excellent excuse for me to have a little node project that I could build here that has a server that can serve up this content. So let's switch to another directory here. CD demo and go to node Reddit, and let's fire up Visual Studio Code on this guy. So here we have a little, I don't want the debug console to be up right now. Here we have a, let me kill these two also. A Node app that uses Express, which is an application server framework for Node. And you'll see that it defines two routes here. One is just statically serve up the React Reddit app as the root. So if you go to localhost, that's what you get. But then we can also serve up the JSON. And the JSON we serve up by calling our getRedditFeed method. And you'll note that I chose to wrote that as an async function. This is the async await stuff that we added in TypeScript 1.7. I'm sure some of you, if you're using C#, you already are familiar with async await. And this is, in a sense, the JavaScript counterpart. This is slated for standardization. We all thought it was going to go into ES 2016, but it looks like it's going to be ES 2017. But it's working its way through the committee. In here, you'll see that what I do here, instead of having to do this callback async style of read file dot then of a promise and whatever, I can actually write my code in sequential style. Now I'm using something called read file here. If we look at the declaration of that, you'll note that this is a little wrapper that we put around the async. So we've sort of promisified a read file method and an HTTP request method by wrapping promises around the callbacks. Now, all of this code, we'll make this code available so you can go look at it afterwards, so we don't have to fully understand what's going on there necessarily. But anyway, basically, let's try to go here, and let's try to compile our code. This is the one time where I'll actually invoke the compiler manually. And then let's try to start up Node on the built version of server.js. There. And then let's try to go here, and now we'll go to localhost 8000. And we'll just try to get the JSON. And you can see that our localhost server is indeed serving up the JSON right now. Now, one more thing we need to do is we need to go modify our client app to talk to our server, because right now it's just talking straight to Reddit. So let's go back to that project. We've got a few windows here, and then let me just get rid of all of this stuff, like that. And I'll save, which causes Webpack to repack it, and now it should be all good to go. Now, instead of, well, let's try to go back and actually just refresh here. I'll go to localhost 8. 8,000. And here we are, now we're hitting our local node server that's in turn hitting Reddit, going through async methods, coming back with the results, serving them back to our React client app that's showing it all. Now, just to prove to you that we are, let me kill that server, and then let me actually try to use node in here, and use, go to the other one, and let me use node debugging. So let me try to actually set some breakpoints in this code using Visual Studio's code support for node debugging. So I'm going to go in here to the debug pane, and I'm just going to say run. And then it says, oh, I've never run before. You need to configure what it means to run this app. We say, well, we're going to run with node. And in here, we want to run built/server.js. And we want to enable source maps. So I'll just save that, and I'll launch. And that launches our server. And now we can actually go set some breakpoints. So let's go to server.ts, and then let's try to set a breakpoint here. Oops. There we go. And let's set one here. And now let's go to the browser, and if the demo gods are with us, if we refresh, we should hit the breakpoint. And indeed, you see this guy flashing. We have hit the breakpoint inside our node server now, which is pretty cool. Thank you. I actually set 2, so I can continue and hit the next breakpoint now. All my async methods have executed, and I can hover and see the results that I got in my local variables and the entire result that I'm serving back. Okay, quick demos here. One other thing I wanted to show is some of the other work we've been doing is supporting JavaScript in TypeScript projects. Now, this sort of sounds backwards, but as you've seen in these demos, we've built up a whole lot of very intelligent infrastructure for grokking JavaScript and serving up type information and giving you great statement completion. And it turns out that a lot of that is actually applicable to plain old JavaScript. Plain old JavaScript, in a sense, is just like TypeScript without type annotations, right? But we can still infer a lot of things because we have a smart compiler. And so what we're moving towards with our tools, with Visual Studio and Visual Studio Code, is actually using the TypeScript infrastructure as our language service for JavaScript. Now let me show you what that looks like in action. Visual Studio Code has already switched to using that. So the latest version of Visual Studio Code, it's enabled. And I can go to, and the code name for this project was Salsa, or is Salsa. So let me fire up just here a very simple file that has nothing in it other than some JavaScript. And you see here a function that is a constructor function, but we don't know anything about any of the types, obviously. So I can say var p equals new person. And we can sort of show you that there's a person function, but we don't know what you're supposed to pass to it. In fact, it's JavaScript. You can pass nothing to it. That's perfectly fine in JavaScript, right? I mean, you can do whatever you want to do in JavaScript. We can help you a little bit. Right? We can try to make you write the code right, but it's JavaScript. Now, one of the things that people do, for example, is to add JS doc annotations to their JavaScript. Looks sort of like this. There's a tool called Google Closure that allows you, or the Closure tools that allows you to type check using these annotations. And what we've done is we've modified the TypeScript language service to understand those in JavaScript files. So we can actually feed them into the very same type checker, and now we can know that when you have this annotation in a JavaScript file, well, that must mean, oh, you mean that this is actually a string, and age is a number, and person is a constructor function, and that means down here, we can now give you statement completion or intelligent help. Hey, you're supposed to give me a name here, so Joe, and 42 for the age. Now, that's cool in and of itself, but where it gets really cool is, let's say I was going to use jQuery. Well, here's the normal JavaScript experience with jQuery, $. Oh, I think it's called Ajax. And then, oh gosh, I don't know. What comes here, right? I mean, that's hard to know. However, someone's already written down all of that information in a TypeScript declaration file. What if we could use that and serve up that information, even though you're in JavaScript, right? So let's try to look at how that works. So what I can do in this project is just create a tsconfig file, and then I can use tsd to install the jQuery type information. TSD is this tool that allows you to install declaration files from definitely type. And so that went out, got that declaration file, sucked it into a directory called typings, and now I can go in, I can modify my tsconfig file, and all I gotta do is say allow.js:true, save, and go back to main.js, type $, whoops, I may have to reload this file. Try to do that. Sometimes it picks it up, sometimes it doesn't. No, we need to reload the project, so let's save it. Restart it, like that. Okay, and now if I say $, lo and behold, I get statement completion for Ajax, and it tells me all of the things that can come next. And this is basically just leveraging work that's already out there, but not forcing you to switch to TypeScript. You can still, it can all be JavaScript if you like. Now let's say that I wanted to also use Lodash, for example, which is sort of the successor of underscore. And now, once I simply install that type information, now underbar dot, whoops, look at this, filter, it knows what the methods are. I can pass it an array like that. And then we can apply all that type information and know that in the callback, X is going to be a number because you gave me an array of numbers, and therefore we can show you all the methods of a number and so forth. And so all of a sudden, all of the goodness comes back. So this allows you to gradually move into a world where you take advantage of all of this information, and you can stop pretty much at any point, as you can see. You could just have plain JavaScript with nothing. Or you can have a little bit of help, or you can go further and rename your file to .ts and actually start writing annotations, if you will. It's entirely up to you where you put the dial. Okay, I wanted to show how in a project like this here, for example, we can actually even mix the two types of files. So I could add a file called utils.ts. And now in here, I could say function makePerson. And then I could say return new. And look, we actually know about this person constructor that you wrote in JavaScript, and we know what its parameters are. And this time, we will actually check. And if you pass it the wrong things, we're going to whine at you and say, no, 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 you need to pass a name, and then you need to pass a number, and then we're good. So we can save that. Then we can go back to main.js, and now over here, we could say p equals makePerson. And in JavaScript, we know about the TypeScript file, and now here we get statement completion and et cetera. So you can mix and match as you see fit and have gradual transition to TypeScript with an existing JavaScript project if that's what you'd like to do. Okay, let me go back to the slides. And let's talk about the future a little bit. So next on our roadmap is TypeScript 2.0. We think it's going to be out in probably a couple of months. So I'd say late May, sometime in June. And the headline of features that we're looking at right now is probably the #1 requested feature is non-nullable types. And I will give you a preview of what that looks like. We're also adding control flow-based type analysis. I'll show you what that is. We're adding down-level support for async await. That's a big work item because it requires us to rewrite our entire emitter backend because we need to do some pretty complicated source transformations in order to support async await on ECMAScript 3 and 5 that doesn't have generators. Other things are read-only properties, and you can declare this types, and we are improving the way you acquire type declaration files. So we're going to look at a few of these here. In fact, but I'm going to spend a little bit of time on the non-nullable type. And I have a couple of little slides here just to give you some elementary type theory here. This is how TypeScript views the world today. We have primitive types built in for JavaScript that are number and string and Boolean. And in those types, these circles are all the possible values of the type, right? And there are all the numbers are the possible values of the number type, but also undefined and null. And the same is true for string and Boolean. And in fact, any TypeScript type you write, we say that null and undefined is a valid value that you can assign to it. And that means we can't check whether a thing is null or undefined or not, because we say that it's always okay. And that means there are certain things we can't check. Now, we also support a feature called union types. And union types are sort of the ability for you to say, oh, this thing is either a number or a string. And it's written with a vertical bar. That's been in for a while, and it's super useful. It's often you write functions in JavaScript to take either a number or a string, and then you, or a number or a string array or whatever. Now, in TypeScript 2.0, we're introducing a new feature called strict null checks, or a new compiler switch called strict null checks. And in strict null checks, we say undefined and null are no longer part of all of the types. Meaning that a number is a number, a string is a string, a Boolean is only true or false. It can't be null or undefined. What we're doing is we're actually extracting them out to be two distinct types. There's a new type called undefined, whose only possible value is undefined, and a new type called null, whose only possible value is null. And then we allow you to use union types to put them together. So if you want to have a thing that could be a number or undefined, well, you just write it as a union type. Likewise, if you want to have a string, but also allow someone to pass null or undefined, you just union them together as string or null or undefined. That's, in a sense, the crux of all of that work. That's really sort of the foundation that it rests on. So let me try to show you what that looks like in the real world here. Let me go to Demo New. Oh, sorry. Yes, I keep forgetting. There we go. OK. I'm going to go into a different directory and just fire up a blank little project I have here. And I'm going to go to main.ts. Here's a piece of code written in TypeScript today. It appears to have no errors, but sadly it does. I'm ashamed. Mea culpa. There are things in here that we should have found that we don't find. I don't know if some of you can see what the problems are, but why don't we have the compiler point them out to us instead? So I'm going to go into the tsconfig file, and I'm going to turn on this new feature called strict null checks. And then I'm going to go back to main. And lo and behold, we now get some errors here. First of all, the compiler is telling us that you use the count variable before you assign to it. Now, this is definite assignment analysis, which is part of this feature. And it tells us down here, too. Then it tells us that text, because text is an optional parameter, it could possibly be undefined, and you're not checking for it here, so this would cause an exception if you ran this code. And then down here it's telling us that you're passing null, but you're supposed to give me a string array, and null is not a valid string. So all of a sudden, all this stuff lights up. Now, let's see if we can fix these errors. And now keep an eye on the type checker here. So let's say that we start fixing it, but we do it the wrong way. Oh, yes, of course, I need to first set count equal to 0. Well, that actually would work inside the loop, but that's obviously not going to work down here. And really, where I need to do that is up here. And then that error goes away. And in fact, I don't even need the type annotation at that point anymore. I can just say count equals 0, and we know. So what you saw here is that we are actually checking all of the various ways that flow or control could reach each use of the count variable, and checking that in all of those branches, there is a value that has been assigned to the variable before you can use it. It's called definite assignment analysis, and that's part of this feature. Now, here's a similar one. Well, not similar, but it's the fact that, because text is an optional parameter, and because down here we could call this method and not pass it anything, that means that we could get the value undefined at this point. And we need to guard against that. Now, one way we might guard against it is just, let's just put it all in an if statement, and say, if text, then do all this stuff. And let's indent all of this. Okay, like that. Well, that sort of takes care of it, but now another problem pops up here. There's no ending return statement in our function, and the return type doesn't include undefined. You've said that you're going to return a number, but if you run this code, it might fall out the bottom and return undefined, and that's going to cause someone downstream to have an error. So we need to fix that. Now, we could fix it by saying return 0 here, and then that shuts up the checker. Now it's happy. But we might also instead maybe have written the code differently. We might have said, well, why don't we say, and this is just sort of the bailout style, if not text, return, otherwise do all of this stuff. And now we're happy down here, but lo and behold, it says, you need to return a value, so let's say return 0. And now we're good. Now, actually notice what happens here. Up here, text is a string array or undefined, but down here, it is a string array, because there's no way that control could get to this point, because we've already, in all preceding code paths, returned. And this is control flow-based type analysis that we're also putting into this guy right now. So we're starting to see a really deep understanding of your code here, right? And it gets really hard to make mistakes. I'm trying best I can here. Now there's one down here, type null is not assigned. That's right, we still didn't fix that. So one way we could fix that is we could say, well, okay, we take string or null. So this is an optional parameter of strings or nulls in an array. And that's good, but now a new error pops up. It says, whoops, line is possibly null or undefined. Oh, well, so we need to guard against that and say line and line.length not equal 0. Now we're good. Now, and this code has no bugs in it. But thank you. Let me show you some other fun with this stuff. Here's another crazy little program. I declare 5 classes, A, B, C, D, and E. And then I have this crazy function that returns an A or a B or a C or a D or an E. And we just infer that from what comes out of that crazy return statement, right? And then I have an even stranger function down here that gets an A or a B or a C or a D or an E. And then it says, if x is an A, now notice what happens to x. Up here, it's an A or a B or C or D or E. Here's an A, because we know you checked. But then you assign a B, well, now it's a B. Otherwise, in this branch here, well, it's a C or a D, or B or a C. But here, it's not a D, so it must be an E. But otherwise, here we return. Okay, pop quiz. Pop quiz, what is the type of X right here? Anyone? Of course, it's B or C or E. This is crazy stuff, right? I mean, but this is the kind of thing that type checkers are excellent at, because they will never make mistakes. And they'll just relentlessly point out to you what the type could be here. Now, another one is nulls and undefined, and all the strange ways that JavaScript allows you to check for null and undefined, but it doesn't sort of always check all of it. Like, here's a test function that can take a string or a string array or null or undefined. Okay, then we do a truthy check. So if S, well, fair enough, then we have either a string or a string array, because a truthy check gets rid of null and undefined. Well, what do you think the type is down here? Interestingly, it is actually string or null or undefined, because an empty string is falsy in JavaScript. This is nuts, right? But the type checker knows. Here's another one. If type of S is object, well, you would think then, what would you think that S is here? Well, you'd think it'd be the string array, right? No, it could be null, because the type of null is object, not null. Whereas the type of undefined is undefined. Okay? And so here we have the opposite. What about this dude? If S double equals undefined, what do you think the type of S is here, possibly? It could be string or null, because double equals checks for both, whereas triple equals only checks for one of them. Look. Crazy. Down here, again, you get the idea, right? JavaScript has some quirks, but you can teach a compiler about the quirks, and you can have him check all of these things, and that's basically what we're doing here. All right, that's a little quick look at that particular feature. Let me go back to the slides because we are running low on time, I can see. Basically, it's a new strict null checks feature, and we do all, and it's really a whole bunch of different features. Most of it is in this pull request that's down there, 7140. You can go look at. One of the things that's cool about it is that it's actually going to be backwards compatible in the sense that you can go update all of your declaration files to include null and undefined annotations. But then when you use them without strict null checking, you get exactly the same results that you have today, which means you can move up to this feature. But of course, all of the declaration files you depend on would have to be moved up there too. And we're looking at adding the capability of tagging a declaration file that it has been updated so that you know and you use, because otherwise the declaration file is going to say, oh no, it never returns null or undefined when possibly it does. Okay, I'm running low on time here. Just briefly, another feature we're working on is improving the way that you acquire type declaration files. We've had external community tools like TSD or typings are what people use today, and they're great tools. But it sure would be nice if we could have one unified view of it all. And the view that we're taking is that there's already a package manager for JavaScript, and it's called NPM. What if we just package type declarations as NPM packages, and then use NPM to do all of the cataloging, acquisition, all of the dependency management between them, and that's basically where we're moving towards. And you can parse the rest of the slide as you look at the slides afterwards. I wanted to just briefly talk a little bit about what's happening in the ecosystem. You've seen me today demo Visual Studio Code. We obviously have all of the same support in Visual Studio. We have the same support in Sublime Text. Indeed, the very same language service is being used by an editor plugin in Sublime Text. And in Atom, the community has built a great plugin for the Atom editor. In fact, in some ways, it does more in some areas than ours. WebStorm has very nice support for TypeScript, Eclipse, Emacs, Vim, lots of tools. Whatever tool you like to use, you'll find that there's support for TypeScript. Community is very active, and I encourage you to go and interact with our team. We're there every day. Stack Overflow, definitely typed. Adoption, it's pretty amazing. Our adoption numbers on NPM are up 15 to 20x over the last year. So we just last month closed, went over 1 million downloads per month on NPM. Now, of course, these are not individual users. This is a lot of auto-provisioned stuff, but nonetheless, there's enormous traction in the community. Lots of people, lots of friends of TypeScript, and if you're a friend of TypeScript, go add your logo to the page, please. And finally, I'll leave this slide up. Lots of frameworks are now using TypeScript to do their development, like Angular is a prime example, but many of the others are doing it, and it's simply because they are writing these huge code bases, and TypeScript delivers precisely the kind of checking that they need to write them safely. And that's it. I filled the whole hour here, I think. I thank you for coming. Please check out TypeScript and let us know what you think. Thank you. Thanks.